quality seed production. Seeds are the beginning of the food chain. To start a new paddy crop, farmers need seeds. Traditionally, farmers use their previous grain crop as a seed source for the next paddy season, or will access seed within their own community, friends and relatives. The quality of the seeds from these sources is uncertain, and they're often a mixture of several varieties. Starting a paddy crop with substandard quality seeds will induce a poor foundation for the resulting rice crop. Those plants often will have a low seedling vigour. The resultant grain quality will be less competitive in the market and fetch a lower price. Rice production requires good quality seeds in order to increase resilience, productivity and rice grain quality. The benefit of quality seed does not stop at crop growth, but will go a long way and impact grain quality, crop yield, livelihood and income for the farmers. The starting point in improving local rice varieties is a quality rice seed production programme. Good quality seed can increase yield of local variety by 5 to 20% compared to local seed admixture. Selection of seed for multiplication. Don't use the wrong seed. Spend some time to choose the right seed to start with. The selected seed for sowing should be of good quality, free from impurities and have a good germination rate. It's preferable and recommended to use the seed from a reliable source. Certified seed from recognized seed suppliers. Seed from fellow farmers whose rice field during the previous season was carefully observed. Owned seed produced following good and proven practices. Even with certified seed and reliable seed sources, human errors can always happen. Farmers have to be very cautious and inspect the seed lot used for quality seed production. Visual selection based on grain colour. It's a general practice of a farmer to perform a final quality check of his seeds right before sowing. Traditionally, farmers check the seeds after opening the storage by performing a visual observation and inspecting first for insect, pest damages and physical appearance. The seeds are usually stored in the granary in buckets, bins and bags. Take some samples from different layers of the storage. Select 1 or 2 pears, about 2 or 3 kilograms. Spread the sample on a smooth surface like the top of a table or the floor covered with a vinyl sheet and mix the contents thoroughly. Divide the whole sample lot by hand into 4 subsamples of similar size. Take 1 milk can of seed from a subsample and spread it on a smooth surface, and count off-type seed, weed seed and red grain. 1 milk can of seed holds about 7,000 paddy seeds and weighs about 175 grams. According to official standard for certified seed, 1 milk can of rice seed can carry at the most the following impurities. Number of off-type seed, 5 maximum. Number of weed seed, 3 to 4 maximum. Number of red grain. 1. If too high number of off-types rice grain are present in the sample, a decision will have to be taken probably not to use this seed source. Using a seed source containing too much admixture from other varieties will be uneconomical for the farmer during the selection and roguing stage. The farmer will have to access a new reliable seed source. Selection of seed by saltwater treatment or floatation method. Unripe grains, unfilled grains, or grains that have been damaged by insects are lighter in weight than healthy grains, so they can be removed using the floatation method. This helps to improve the quality of seed selected for sowing. Prepare a solution of salt and water using 1:4 ratio, such as 1 volume of salt for 4 volumes of water, or locally use 1 vis of salt, 1.6 kilograms of salt, for 4 gallons of water. A local method which allows to check the salt density is the immersion of a raw egg in the salt water. If adequately dense, the tip of the egg should float at the surface of the water. If the egg sinks, add more salt. Immerse the seeds. Stir the seeds upon soaking and discard those that float on the surface. Remove the light and unfilled seeds. They can be used for livestock feeding. Finally, wash the filled heavy seed remaining at the bottom with fresh water. Wash thoroughly to ensure that the seeds are properly cleaned off of the salt solution. Incubation and pre-germinating seeds. Incubate the seeds for 24 hours in a warm and shady place protected from the wind. To keep them warm, seeds can be incubated in moist jute bags. Take care of neither having too thick a layer, as temperature builds up and uneven temperatures can be damaging, nor too thin a layer, as it will not promote optimum temperature. About 10 centimeters thick layer is optimal. Check by hand for optimum temperature. Locally, sometimes farmers can use a lungi to perform this operation. The cloth, being thinner, regulates optimally the temperature between outside environment and incubating seeds. Allow room in the sac for expansion of the seeds during incubation. Incubation keeps the seeds warm, increases growth of the embryo, and results in uniform germination. Observe the white root or radicle emerging from the seed. If sowing is delayed, the roots grow and get entangled, making it difficult to sow the seed with appropriate spacing. The right time for sowing is based on the length of the sprout. Locally, it's said that the sprout should be like a sparrow beak, or about 5 mm in length. For optimum incubation, the seed should be kept neither dry nor soaked, but moist. Nursery management. For quality seed production, only 1 or 2 seedlings per hill will be transplanted in the main field. Because of this minimal number of seedlings transplanted, we need to make sure that strong and healthy seedlings will be available to the seed producer. This can be achieved through an appropriate raised bed nursery technique. Seeding in the seedbed ensures proper and vigorous growth of the parental seed material. The seedbed provides a healthy and vigorous environment for seedlings' growth and facilitates optimum water management. Seeds can be easily sown at optimum spacing, avoiding overcrowding and induced diseases. Seedbed promotes adequate nutrients for seedlings' growth, and competition for nutrient can be avoided at early stage, particularly after the first 2 weeks of growth, further facilitating root development, nutrient uptake and absorption at root level. In a conventional nursery, the seedlings get affected and disturbed by incoming tide, whereas raised nursery beds protect the seedlings from tidal water movement. Uprooting seedlings from raised beds can be performed without damaging seedlings and roots, ensuring a quicker recovery of the seedlings in the field. Raised bed preparation. For 1 acre, the nursery bed can be raised in about 50 square metre plot, depending on varieties. Either single bed or several smaller beds can be prepared. Locally, 5 to 6 beds of 10 metres long by 1 metre's width are prepared for easy management. The seed bed should be preferably prepared in a corner of the plot and not far away from the main field for facilitating quick and efficient transplantation. A bed with a width of 3 to 4 feet is ideal. The length of the bed can be decided by the farmer depending on the field condition. It's recommended to puddle the seedbed field twice at an interval of 7 days to destroy any germinated rice seeds from the previous season or weed seeds. Locally, farmers will prepare the seedbed plot 1 month in advance by ploughing once, then harrowing a few times according to soil condition, then puddling. 1 day before the seedbed formation, another tilling will be performed with a power tiller. Plan for drainage channels between seed beds and on all sides to drain excess water. The nursery bed should be prepared with application of farmyard manure and rice husk charcoal, and according to the farmer's habit for fertilisation. Mix adequately the soil with manure. Locally, farmers will apply compost one day before and use the pot method to form the raised beds. Add water in the pot to weigh it down. The pot will form ridge sides and water channel. Compost facilitates easy penetration of roots and provides nutrients for the seedling's critical early growth. Roots of 21 to 30 days seedlings grow up to 8 to 10 centimetres, so it's necessary to prepare raised beds 12 to 15 centimetres high to ensure adequate root development. Sowing in nursery bed by broadcasting. Ensure uniform broadcasting of the seed on the raised bed. Use about 1 kilogram of pre-germinated seed for a 10 metre long by 1 metre wide raised bed. Seed should be widely spaced, half to 1 inch, to avoid crowding, and care should be taken that seeds don't touch each other. After sowing, cover the nursery bed with rice husk charcoal. Covering the seed bed after sowing conveys several advantages. It protects the germinating seed from raindrop impact. During high tide or floods, the rice husk charcoal prevents the seed to be carried away. It protects against direct exposure to sunlight and avoids wide temperature fluctuation. It also protects against bird and insect predation. Optimum seedlings age for transplanting. The optimum seedlings age for transplanting will depend on the life cycle of the local variety. Ideally, between 21 to 30 days old seedlings will be recommended, depending on varieties and local condition and constraints. Uprooting and selecting seedlings. The action of uprooting seedlings from the nursery bed is a very delicate process, and great care should be applied at this particular phase to promote uninterrupted and continuous plant growth. Do not pull too hard. After 21 to 30 days, when the seedlings attain 5 to 6 leaves, the rice plantules should be transplanted. Good preparation of seedbed with compost and rice husk charcoal will help to easily remove the seedlings. While uprooting the seedlings, unhealthy plantules will be disregarded, and only healthy and vigorous seedlings will be selected for transplanting in the field. Bundling. After uprooting, seedling roots should be washed off of excess soil and should be bundled with up to 150 seedlings per bundle. Finally, each bundle should be tied with care not to break or damage leaves, and then the bundles will be ready to transport to the fields. It's recommended to transport the seedlings to the main field with a container, such as plastic or bamboo baskets, to avoid damaging while bundling. It also makes it easy to distribute to transplanters. Plot selection for quality seed production. Select a good fertile plot with adequate drainage. Select a plot free from pest and disease incidents, based on the previous year's observation and farmers' experience. Identify the right size in accordance with and matching the quality of seed to be sown. Proper and well-built embankment bunds are essential to visually and physically isolate from other varieties. Select the optimum plot. The seed production plot must be well separated or isolated from other paddy field production to ensure genetic purity of the seed, and set far away from wild rice, which can easily contaminate the crop. Pollen from different rice cultivars near the seed production plots can contaminate the parent seeds and lower the quality of the harvested seed. Rice pollen grains are small, light, and can be carried up to 100 metres during their short 3 to 5 minutes lifespan. Grow the same varieties for seed production and paddy production on adjacent plots, to avoid cross-pollination with pollen of other rice varieties. At the ripening stage, clear and rip 1 metre all around the seed plot for isolation purpose and to avoid mechanical mixture from neighbouring plots. Land preparation. Proper land preparation is necessary to minimise competition with weeds, promote uniform growth and unfluctuating water levels. Perform adequate land preparation according to farmers' habit and best practices. Plough once or twice and harrow several times to make a good tilt. Perform land preparation as early as possible to allow the volunteer rice plants to grow. Let the volunteers grow first, then plough the field to eliminate volunteer rice plants and weeds. It's recommended to perform recurrent ploughing at 7 days intervals and at least 2 times. It's ideal for early control of weeds and volunteer rice plants. The surface of the field should be made as levelled as possible. A well-levelled field ensures uniform water depth throughout the season and contributes to uniform ripening across the field. A well-prepared and levelled field favours crop establishment, results in better crop stands, facilitates care operation, results in uniform crop maturity and stimulates yields. Transplanting. For quality rice seed production, transplanting should be done in rows to facilitate roguing off types as much as to simplify a number of important field operations. This method of transplanting provides proper plant spacing, resulting in uniform and vigorous plant growth, promotes optimum crop stand, maximises seed yield, and facilitates field operations such as weeding, spraying, observation and roguing. Only 1 or 2 seedlings per hill are recommended. When inspecting and roguing for off-type, if many seedlings have been transplanted per hill, it will be difficult to identify and pull off the off-type. On the contrary, the entire hill will have to be disregarded, inducing less yield and economical loss for the farmer. For transplanting, it's recommended to use line transplanting with markers at every 10 inches. This will assist in respecting a straight line pattern and a proper distance between plants. Transplant 6 rows and skip the 7th row. Go on transplanting following the same pattern. Seedlings should be transplanted straight and upright for early establishment. Depth of transplanting should not be deeper than 3 centimetres for early plant recovery and better tillering. Too deep transplanting will induce elongated internode at early stage, which will delay tiller production. Water level management during transplanting. If possible, drain the field during 3 days to encourage faster rooting process. A drained soil will optimise rooting because of its higher air pore structure. Furthermore, water movement in the field may disrupt and uproot seedlings at early stage, whereas a drained field will eliminate this risk and the impact of water ripples and tidal disturbance. Try to transplant in the low tide period, generally 1 week after the full moon. Local farmers have experience with low tide period and use the lunar calendar to prepare raised beds and plan transplanting date during low tide to ensure best water management. Weeding. The practice of transplanting rice seedlings gives the crop a competitive advantage over the weed's development. Standing water is an additional factor reducing weed pressures. Weeds decrease yields by direct competition for sunlight and nutrients. Keep the weeds under strict control. Weeds can be controlled by hand pulling or by mechanical means, such as the use of a weeder. Herbicide usage is not recommended. It's suggested to follow the SRI principle of weeding using an interweeder, or if it's not favoured by the farmer, perform weeding by hand. It's recommended and it's encouraged to start weeding early in the season. Weeds are characterised by fast growth and will compete with rice plants during their early development stage for nutrients and light. During early stage of the rice plant development, it's easy to enter the field and complete weeding. Later on, with canopy development, it will be more difficult to access the rows. Make sure that the plants are properly anchored into the soil before starting the first weeding. Locally, farmers start weeding 15 days after transplanting to minimise disturbance of the rice plants, and go on checking regularly for weeds during field visits and field inspections. It's recommended to weed regularly to eliminate early competition for nutrient at root level, and up to 1.5 months into the rice growth. After 1.5 months, accessibility inside the plot, physiology and interaction between weeds and rice plants create a combination of factors not effective anymore for hand pulling or use of an interweeder. Start weeding early and regularly to ensure best rice development. Roguing. Roguing is the removal of undesirable rice and diseased plant from the quality seed production plot. Roguing prevents off-type plants from cross-pollinating with the chosen variety and lowering the quality and purity of the quality seeds. Undesirable rice plants may be volunteer plants from an earlier crop or off-types resulting from seed mixtures. Off-type plants can be removed at 3 stages of plant growth: maximum tillering stage, flowering stage and maturity stage.